Hello everyone. We're going to be talking about reciprocal functions. So reciprocal functions are something that if I'm giving a function f of x, for instance this blue graph here, this blue linear line is f of x, the inverse function is defined as 1 over f of x. We can take a look at this from a transformation point of view. If f of x has a point xy, we can graph the reciprocal function by simply taking the reciprocals of the y coordinate. So point xy is on f of x. That means that point x1 over y is on the reciprocal function. If I was to graph the reciprocal of this blue line, it would be this. The red is the reciprocal function of the blue. Some interesting things to note are it appears that this graph has a horizontal asymptote at y is equal to 0, which is correct. It appears that this function also has a vertical asymptote at x is equal to 1, also correct. Now, let's take a look at another function that we're going to graph. So I have defined a function f of x. Let f of x be x squared minus 4. Now I've graphed this as seen here. The reciprocal function 1 over f of x is equal to 1 over x squared minus 4, which is simply the reciprocal of the set of instructions for my function f. It is interesting to note that notation kind of is goofy. We can also write this as y is equal to 1 over x squared minus 4. In other words, this is a rational function. You know how to graph a rational function. You're probably able to pick out that this will have a horizontal asymptote at 0. And if you factor the bottom, we have two vertical asymptotes at -2 and 2. Now look at the graph of the blue. Looks like we have two zeros there. Anyways, allow me to talk about this. This is an introduction. We'll go into this much more in depth later. So if we have point xy for the blue graph, I'm going to attempt to graph the reciprocal. So what do? I simply make a table of values for my regular function f of x. I certainly hope that these are the points on my graph f of x. If I graph the reciprocal function, now I don't know what that looks like quite yet, but here I have my reciprocals. And when I say take the reciprocal, remember when we're applying the transformation, it's really just taking the reciprocal of the y value. So 0.335 will become -3.5 will become 0.315. We're taking the reciprocal only of the y. -2, 0 becomes -2, 1 over 0. And I know some of you guys are cringing because you cannot divide by 0. Let's continue anyways. -1 becomes -1, 1 over -1. 0, -4 becomes 0, 1 over -4. 1, -1 becomes 0.1, 1 over -1, etc., etc. When we graph this, we'll end up with the reciprocal function that looks like this. This is exactly what you would have done if you would have graphed it as a rational function. But let's stick with the small stuff, shall we? Here are very, very important ideas. Students often have troubles with these simple number ideas, and we're going to be building a lot off these ideas. 1 over a positive number is a positive number. In other words, the reciprocal of positive is positive for any positive number. The reciprocal of a negative is a negative. So 1 over -4 ended up being negative quarter. The reciprocal of a small number is big. For example, 1 over 0.0001 is 1,000. So the reciprocal of a small number, being close to 0, ends up being a big number. Last but not least, the reciprocal of a big number is a small number. So for instance, 7. Is it big? It's moderately big. 1 over 7 is small. It's 1/7, very close to 0. Some important ideas. We're going to run into some similar themes along with some rational function review as well. Stay tuned, shall be fun.